Hello everyone. Good morning, good night, good evening to you. Welcome again on the second day of Advent of Code 2019. Yesterday I woke up 10 minutes before 6 to solve the first challenge. I was very sleepy. Today I woke up a little bit earlier. I did some burpees already to get the energy going. I hope this time I will be a little bit more focused than yesterday. Although it did make me a little bit short on breath, but we'll see. It's quite a challenge, the programming, the timing, the amount of puzzles every year. I'm not even sure if I'm able to do all of them this time. Last time I did about 7. Enjoyed it very much. Some of them were very tricky and I didn't finish them. Some of them were so much fun I spent the next 3 months working on a project based on top of it. I'm talking about the puzzle where you had to solve the water simulation. I built an entire cellular automaton afterwards that could solve that puzzle. I see that it's already 6 o'clock, so I'm going to refresh this page and go to the second puzzle. I'm also going to start by downloading my input right away. There we go, save this input, and I'm going to quickly go through the text. I might be able to get on the top of the list if it's an easy one. Day 2, 12:012 program alarm. On the way to your gravity assist around the moon, your ship computer beeps angrily about a 12:012 program alarm. On the radio, an elf is already explaining how to handle the situation. Don't worry, that's perfectly normal. The ship computer burst into flames. You notify the elves that the computer's magic smoke seems to have escaped. That computer ran IntCode programs like the gravity assist program it was working on. Surely there are enough spare parts up there to build a new IntCode computer. Sounds like we're going to have to build a computer. That's the exercise I didn't do last time. An IntCode program is a list of integers separated by commas. Let's look at our input also to get an idea. I see, it's not a very long list. To run one, you start by looking at the first integer called position 0. Here you will find an opcode, either 1, 2 or 99. I'm going to make some notes already. 1, 2, 99 unit opcodes. The opcode indicates what to do. For example, 99 means that the program is finished and should immediately halt. And encountering an unknown opcode means something went wrong. So these are some opcodes. Okay. Opcode 1 adds together numbers, read from 2 positions and stores the result in a 3rd position. So that as I suppose it follows, 2 numbers follow it. The 3 integers immediately after the opcode tell you these 3 positions. So add A and B and output to C. I'm double checking if A and B are actually the integers or if they are memory locations. Yeah, they are. They are positions. So they are the positions in the stream. So that means that the script is both memory and program. Okay. For example, if your IntCode computer encounters 1, 10, 20 and 30, it should read the values at positions 10 and 20, add those values and then override the value at position 30 with their sum. Opcode 2 works exactly like opcode 1 except it multiplies. Okay. Again, the 3 integers after the opcode indicate where the inputs and outputs are, not their values. Yes, important to get that one right. Once you're done processing an opcode, move to the next one by stepping forward 4 positions. Okay, for example, suppose you have the following program. Okay, I think I get the point. I'm just reading through it very quickly. I'm not going to read everything out loud. Yeah, so the program actually changes. That's interesting. And you can store infinitely large integers into this program. I'm assuming this also. And when you read 99, you're done. The first step is to restore the gravity assist program in your puzzle input. To do this, before running the program, replace position 1 with the value 12 and replace position 2 with the value 2. Yeah, that's nice. Last time I messed up because I didn't read until the very end. So let's first read our input program. Open. Let's call them codes. Code for code in. We need to read only the first line and split by this thingy. I'm going to strip it also. We actually need to increase our position to read the next ones. Let's see. So it is A plus B into C. value A. Position A is going to be the opcode position +1. Position B is opcode position +2. And out position C is opcode position +3. And then we're going to read those values. And value C is not necessary. And then we're going to add value A, value B. Oh yeah, value C is important, so we're going to calculate it. And then position C will be replaced by the value C. And then we are going to increment our position by 4. And I suppose we do that every time, right? Alright, so that was extracting the 3 positions. I'm going to extract that into a function. And we're going to use the position as a method parameter. Perfect. Arguments for position of code position. And this one will return tuple of val A, val B, and position for C. Here we can extract them. Redeclaring val C. Oh, should be value A and B that we're returning. Okay, this is just a bit of theme stuff. There we go. So we can do the same thing for multiply. We will just multiply, and otherwise we're going to break, and then at the end we're going to print our positions. We're going to join them. Well, it would be very cool if it worked right away. We have a list of integers and it cannot join that. It's fine. Okay. This is our input. Let's see. That's not right. Okay. So now let's be a bit more careful and see if what we are doing is really correct. So the first example is this little program. And then there were only 3 opcodes, right? 1, 2, and 99. And we go for further. Let's see. After every iteration, I'm going to print. unresolved reference. Right. So the first four integers 1, 9, 10 and 3. Those. Just going to add some debug statements here. Operator A, B, C. And for those we have the parameters plus A, plus B, C. Oh really? We can't just convert? No way. 1, 2, 3, 1, 2. Oh yeah, I'm missing one string parameter. So what do we get? I'm going to remove this default argument. Okay. So the first operation we're doing is 1, and it has 9, 10, and 19 as arguments. But instead here, just getting the positions. Oh no, that's actually fine. Oh right, those are the positions. The values, I actually have to dereference them one more time. Hold on a second. So these are basically the argument A position. Oh god, this is confusing. Argument B. And then argument C. And the actual position of the... So A is referring to a certain position in the list. A is the first argument. And this position is this one. And position B is positions are B. And then we need to go like this. Actually get the real values. So we're doing I think we also need to do position C here. Yeah. Like that. Okay. And then we should get 1, 9, 10, 70. And the output is like 3500, 9, 10, 70, 2, 3. Okay, I think now I got it right, and I'm going to run this on the whole input. It's also not right. Oh my god. Hey. Let's see what's going on. Am I printing at the right point? I'm printing at every loop. Unless I break. So I should definitely print one more time at the end. Yeah, I'm afraid I'm being blocked right now. I probably cannot submit right now. I have to wait a little bit. Problem. Although it does look like my last two outputs are exactly the same. That is going to be a little bit hard to know for sure. can I do to check this? And I'm going to compare with clipboard. Compare with clipboard. Contents are identical. Okay, so it's better I don't submit that right away. Right. Here are a few more programs to try out. Program 1. It's like this. The output would be like this, that's correct. E2 230699, that's also correct. E3 244599 244599, that's 9801, that's correct. And then the last one, (301142) 56099. I think I got it all right. So yeah, I didn't compare the right. No, it's still not right. Okay, so I'm going to read a little bit further, but I'm very confused because all my examples are correct. Does that mean I'm reading the wrong input? That cannot be. Right. Let's print the input right away. But they did say that I had to fix some positions. Maybe that's the problem. Once you have a working computer, before running the program, replace position 1 with the value 12 and replace position 2 with the value 2. What value is left at position 0 after the program halts? Oh, come on. It's this one. Yeah. Oh, yeah. Alright, part 2. Good, the new computer seems to be working correctly. Keep it nearby during this mission. You'll probably use it again. Real IntCode computers support many more features than your new one, but we'll let you know what they are as you need them. However, your current priority should be to complete your gravity assist around the moon. For this mission to succeed, we should settle on some terminology for the parts you've already built. IntCode programs are given as a list of integers. These values are used as the initial state for the computer's memory. When you run an IntCode program, make sure to start by initializing memory to the program's values. Program's values, okay. A position in memory is called an address. For example, the first value in memory is at address 0. Opcodes like 1, 2, or 99 mark the beginning of an instruction. Yes. Yeah, alright, so what I was doing here, get arguments, I should call it get instruction, sort of. In the instruction 1, 2, 3, 4, 1 is the opcode, 2, 3, and 4 are the parameters. Okay, I'll stick with parameters then. Right. The instruction 99 contains only an opcode and has no parameters. Oh. Okay, that means that after 99, theoretically, you should not skip 4, perhaps. The address of the current instruction is called the instruction pointer, which I call opcode position. Okay. It starts at 0. After an instruction finishes, the instruction pointer increases by the number of values in the instruction. Yep. So that means I'm going to skip 4 here and skip 4 here, and here technically I should skip 1, but probably it's not relevant. Yeah, for now it's always 4. The halt instruction would increase the pointer by 1, but it halts the program instead. With terminology out of the way, we're ready to proceed. To complete the gravity assist, you need to determine what pair of inputs produces the output. What pair of inputs? Isn't that just a factoring question? Like, which two numbers multiplied together or added would result in this? Input should still be provided to the program by replacing the values at addresses 1 and 2. Just like... And in the end, are we going to share the whole program? Find the input noun and verb that cause the program to produce the output. Okay. You need to determine what pairs of the input should still be provided to the program by replacing the values at addresses 1 and 2, just like before. In this program, the value placed in address 1 is called the noun, and the value placed in address 2 is called the verb. Each of the two input values will be between 0 and 99 inclusive. Once the program has halted, its output is available at address 0, also just like before. Each time you try a pair of inputs, make sure you first reset the computer's memory to the values in the program. In other words, don't reuse memory from a previous attempt. I see, okay. So we have to try around 100 by 100 combinations. I think that's doable. We just need to make sure we reset our input. So we have input program and we need to fix it. I'll extract that into a method. Actually, I'll call it reset. Not sure if this is going to work. Seems like it. So we're going to try every combination. For noun in 0 to 99. Maybe range. For verb in range 0 to 99. We're going to reset. So we don't need to reset here. Well, you know what, I'm actually going to commit my code before going to the second part. Alright. I'm going to reset. I'm not going to reset at first. The instruction pointer should also be set to 0. Anything else we need to reset? I guess not. Pointer, the memory, and the fixes. And then we're going to override those positions. Ah, yeah, those are these two positions actually. Verb. And then we're going to have to run the whole program. Okay, let's see, and then we need to know when we are going to get this up. And the program will return, in fact, value at position 0, but it's a global, so we are just going to read it. So the noun is noun and the verb is verb, and the answer is going to be a little calculation. And the answer will be 100 times noun plus verb. Now we get some problem with globals. Perhaps like this. Might take a very long time, and we're not going to print positions at every step, especially not opcodes. Let's restart. Oh yeah, I will also need to break, most likely. One more time. Okay, let's see. Now, of course, the fact that we're doing Python is in our disadvantage. Oh. Seems like nothing is happening. At least it's not printing any statement for the outer loop. It means that it's going to be very slow. This that is a bad sign. Maybe we're not getting any output. Wait, that's because I inner loop. Yeah, the word wrapping is a bit confusing here. So our first program is actually it ran, and our second program seems to be stuck. And they say that it could be anything between 0 and 99. And I'm also curious if range includes the last number or not. It doesn't, so means going to have to use 100. I'm going to print the position of the instruction pointer. So here we see that it's at 0 all the time. It never ends. It starts at 0. Very strange. What happens when we read opcode 0? I'm going to also print the program. So our program is like this. Okay, it looks like the resetting didn't work at all. So instead of reset, I'm just gonna call it load program. And perhaps the instruction pointer. Yeah, it starts at 0, so that part seems to be working. Maybe we can do it like this. Okay, Python append list to list. Extend. I think that's what I'm looking for. Okay, it looks like now something is actually happening, and this is the output program. It finished. And it didn't actually find the output. Its output is available at address 0. First reset the computer's memory. Don't reuse memory from a previous attempt. Yeah. Okay. And I'm breaking here, so that means that I'm actually continuing. So I might have the answer in here somewhere. So it looks like I don't. In Python you don't have to, you cannot break an outer loop, so you always need to use a function to do something similar. Run it again. Yeah, here is the answer. Yeah, site. Ah, so giving you a hint actually. Nice. Too high. Yeah, that's very confusing actually, because since all we are doing is adding and multiplying, it should be quite a big number. Unless we're multiplying by 0 every now and then, of course, which is technically possible. Let's have a look. Okay, you're using JavaScript, I see, and this is your input. First int, second int. Yeah, I think you have the same bug that I had actually in part 1. I think what you did is correct. So you're reading, you're having a certain instruction position and you know which position is the operation on. So here you have the operation, but the first integer, hold on a second, the first integer, this is actually the position of the first integer that you're reading here. So you shouldn't add the first integer and the second one, because then you're adding the positions. So you need to read, well, maybe, let's just stop right there. I guess you got it, yeah. Go, go! You might be still quite high on the list. I guess C programmers would have no problem with this. They are so used to references and memory addresses and dereferencing pointers to pointers and stuff. I guess that's what it is. It's a double reference. We have the position pointing to... no, we have an instruction at a certain position. And we have 3 following pointers that point to the positions of other values. Double dereferencing. I think that probably every single non-C or coder of languages that don't have references are going to fall into this trap. You got it. Congratulations. Yeah. I had exactly the same problem. Okay, then you still have a little bit of work to do for the second part, so good luck with that. Sure. Well, if any other people are stuck, feel free to tune in and get your code debugged. I'll wait for a few minutes, see if anyone else wants some help. Let's see how I can communicate this. No one will be able to read this. Oh yeah, I have my whiteboard, why not? So, I'm going to switch to whiteboard. I'm writing a little announcement here. I'll help you debug your code. I hope people can read that. It's quite small. In the thumbnail at least. Advent of code, I'll write it a little bit bigger. Live help. Thanks for that, HB the Great. I would never have come up with this idea myself. Live help. That's fun. It's working. Wow, that's very fast. Good job. How did you solve it so fast? That's creepy. Do it like this. No, it's still creepy. Like that. Just got lucky on this one without bugs. Yeah, that's always very lucky. I like to think that after I write my program and I got all the concepts